Good morning. Okay. So before we get started, I guess I need to introduce myself. I'm Nawajish Noman. Some people call me Noman, that's easy. And my colleague, Tania. Tania Lopez Cantu. So we both work in the software development in Redlands, okay? Today we're gonna talk about ArcPy, but our focus is working with Raster, okay? Let's see what we're gonna talk about. So a lot of outline here. What you can do with Raster in Python, pretty much everything. And we need to talk about the module that you need to use. And the most important thing is Raster Object. Then we're gonna talk about the visualization and exploration and Raster data management. And the most important thing to me is Raster Analysis, because we are from analytical team, okay? And then NumPy Array and Raster, custom analysis. The most important thing is what Tania is going to show you is the demo. Everything is in action, okay? So working with Raster using ArcPy, what are the things you can do? I already said to you that pretty much everything, but what it means by everything, right? Our objective is whatever you can do in desktop, can you do using programming, right? Visualization, exploration, data processing, batch processing, workflow automation. That's where we most of the time use programming. Data management. Nowadays, you have a lot of data, so you just don't want to do one by one, right? Data management and Raster analysis. And eventually, you'll say, I need a tool that you don't have. This is where your custom Raster analysis comes in, okay? So what you have at your disposal to do all this thing, we have Python APIs and two different kind of Python APIs, right? One is ArcPy, which would be the focus of this session primarily, which is desktop app and ArcGIS Pro local processing, but you can also do it, use ArcPy in notebook server. Then we have ArcGIS API for Python, which usually used in the context of ArcGIS Enterprise, ArcGIS Online for remote processing, okay? So if there are some overlap, but don't worry about it. This is just a broad classification so that you understand which one you want to use for your work, okay? How many functions we have? A lot of them, right? So depending on where you look at, you can see a lot of things, and that's a general bucket of different kind of things. This is not a comprehensive list, but just to give you an idea, the different kind of work that you can do, okay? Now, of course, our focus here is raster and imagery analysis. That's what we're going to show you, and pretty much a snapshot of that, not everything, okay? But we will get you started so that you can really figure out what else you can do in a very simple manner, okay? Now, if you are a Python programmer, how many of you use Python on a regular basis? All of you, right? So you know what is module and importing, so I'm not gonna tell a lot of things about it, but the two modules that you need to pay attention to is the IA module and SA module. And these are the two modules you want to take advantage of when you are doing raster analysis, okay? Like all modules, it has to be imported, and how you want to import it is your preference. What I say here is kind of my preference, and it is based on some other thing that we regularly do. Okay, so you can import ArcPy, and then you can import a module. See, you see from arcpy.sa import star, and many of you probably already cringing and say, oh, that's not a good way to do it, okay? So I'm not gonna debate on that. We're gonna say why we do that. Sometimes we write Map Algebra expression, we write operator, and it's much easier for us to write a very compact expression if we import module in this manner, okay? And you will see that in an example. Now, the heart of all this raster analysis is actually raster object, okay? That is very important, okay? As we go through this session, you will see I will draw focus to raster object, and in demo, you will pay attention how we are using raster object. It represents a raster in ArcPy, okay? It could be a single band raster, multi-band raster, multidimensional raster, any raster. Could be an image survey, anything, okay? Now, what is a raster object? It is an output from Map Algebra expression pointing to a data set, okay? Or you can have a data set and you can create a raster object pointing to that data set. Or you can create an empty raster object, okay? And then populate all the pixels. So a raster object could be anything that represent a raster, okay? Now, one thing to remember, and this is where SA and IA module is different from everything else, that what you get in the left-hand side is not a result object, but a raster, and we'll talk about that again and again. But the most important thing is that one is a temporary thing. You have to save it. Why? When you work with raster, you do a lot of modeling. And like any modeling, not all of your output you need, those are intermediate output, and you don't necessarily have to manage it yourself, you can let it go. So by default, most of them are temporary, you just save the one that you need. Okay, that's kind of the philosophy, why we did that way we did. Okay, it also goes well with the map algebraic expression or map algebra. Okay, many properties describe the associated data set. Okay, many methods to work with properties and bands and multidimensional raster, which is very important, and a read-write method. So if you look at it as a whole, this slide will try to capture the essence of it, okay? A raster object is created from a raster data set or output from a map algebra expression or a raster tool that we run, or you can create an empty one. Now we have properties, we have methods. Now there is one important thing, which is raster. The first argument is in raster. Of course, you need a raster to create a raster object. And then the second one is it a multidimensional raster? If it is a multidimensional raster, you have to say true. Otherwise, it will just take the first slice and create almost like a single band raster. So you are not getting all the slice and dimensions and stuff like that. So that's kind of a little thing that you have to pay attention to, okay, when you are creating a raster object from a multidimensional raster. What is a multidimensional raster? We use the term all the time. It's a cool term, but is it really confusing? I don't know. It's not really confusing, because nowadays you come across data that are pretty much multidimensional because something changed with time. So you have a time dimension. You have X and Y and time. It's a multidimensional raster. You look at something that changes with altitude. That's a multidimensional raster. Something changed with depth in the ocean, multidimensional raster. So if you have X and Y and then you have another dimension, that's a multidimensional raster. We do have multidimensional raster. We do have multidimensional feature. I'll be demonstrating multidimensional feature at 1 o'clock in the demo theater too. Okay. So we have multidimensional raster, which is spatial and temporal dimension. It may contain one or more variable. What is variable? Temperature, pH value, different things. Whatever you are capturing, those are variable. So if you have only one variable, you have a cube. You have multiple variable. You have many cubes, hypercube. Okay, and multidimensional data set. Earlier, we said it was a NetCDF file. Then we went to mosaic data set, but it could be a CRF. Nowadays, we use CRF multidimensional all over the places. Okay, that's becoming our de facto standard. Okay, and you can see that you can do the visualization when you actually use ArcPy, visualization of this raster object or the raster you're looking at, and we have renderer to apply symbology to it if you want to do. But you can also do other kind of changes like contrast, brightness, convolution, pan sharpen. All those methods are available to you if you actually want to visualize it. If you want to understand your raster data, what you have there, what is the cell size, what is the extent, how many slices you have, all those information which are very important when you are trying to do analysis, there's a long list of properties that you can interrogate and you can find out, okay, what's going on. Okay. Now, for raster data management and batch processing, we have a series of functions that you can use. And those functions pretty much correspond to all those tools that we have. So if you want to automate the heck out of your workflow and data management, ArcPy is the way to go. Python is the way to go, okay? How many of you have had to project multiple raster or clip multiple raster? Anybody had to do it for your project? Probably many people, right? So, it's so obvious that we don't, sometimes we just don't have to talk about it anymore. So raster data management in ArcGIS, there are many ways you can do it. You have a raster data set that represents a single raster data set. You can have mosaic data set where you can actually put bunch of raster and you can present it as a seamless layer. You also have RasterCollection that helps with analysis. So RasterCollection is really another important thing, and sometimes we miss it, okay? Because if you create a RasterCollection, you can have properties and method, and you can actually run bunch of operation on the fly, and it's happening with all your raster at the same time, which is kind of cool, okay? So with that, I'm gonna hand it over to Tanya to show you some of these things in action.
Hi, everyone. Yes, so as Norman mentioned, I'll be showing you throughout different demos the different things that Norman is talking to you about in the slides. And in this first demo, we are going to look at the basics of the raster object and how to read raster data, explore its properties, visualize it, apply preprocessing, and also a little bit of batch processing. So the very first step is to import the relevant modules. And here I'm also importing the spatial analyst and the image analyst modules because we're going to be using some geoprocessing functions in this demo. So I'm also taking out those extensions. And the next step is to set my environment workspace. This is a path where the raster data that I'll be using is stored. So right away, we start with reading a raster data set. And how do we read it into our notebook? Is by creating a raster object. This is the specific syntax. This elevation raster is, as I mentioned, is a raster that is stored in this workspace. And with this syntax, I'm creating a raster object. Now, how do I visualize it? Simply by calling that variable in my Jupyter notebook. This is how my elevation raster looks like. Now, you can do a lot of different things with raster object. We can look at the properties and we can apply some methods. And you can take a look at the ArcPy raster documentation for the full list of properties and methods with their respective descriptions. But here I have a list of all of them. We can take a look, for example, at the raster attribute table if the raster has one. And we can also look at the extent, many different things. But how do you actually access one of the properties at a time? The raster object that you had already defined dot the property that you're interested in. And in this case, I am interested in knowing the number of rows, so I'm calling this height property, and this is what it returns, the number of rows in my raster object. Now, imagine that you want to create a new raster, but with properties that, with the same properties of a raster that you had already defined before, a raster object that you had already defined before. The get raster info method, it's very useful for this specific task because it gets all the information of the properties of a raster object that you had already defined before, stores them in a new object, which is the raster info object. And you can pass that to, again, a raster to create an empty raster with the same properties as one that you had already defined. This is going to be very useful for in later demos, so you will see why I'm showing you this as part of the basics. Now, if you want to see all the properties at the time, you can use the JSON library, and basically that raster info object where we grabbed all the properties from the raster object, we pass it to JSON loads and JSON dumps to basically display everything at once. We can take a look at the extent and the cell size, the pixel type, etc. Now, let's take a look at some data preprocessing. And Norman mentioned during the presentation the clip function. We often have a raster that it has a greater extent than a study area that we're interested in. In this particular case, this orange box is defining the study area that I want to do some analysis at. So I will clip my elevation raster object with that specific feature layer using the clip function. And again, you can display it this way, but if you want to display it a little bit with a better visualization, you can use the render function and pass a appropriate color map. And that would also enable you to visualize your raster more, I guess, in a better way in your notebook as well. One more thing that Norman mentioned is that whatever function that you are applying to a raster object creates another raster object, but it's temporary, that doesn't persist. So if you want to save it, you need to use the save method and specify a output path. That way you can persist that specific raster. Now, how do we do batch processing? Say we want to apply the same clip function to many different rasters. So the way to do that is by using the function list rasters. This is super useful. What it does is, once you have defined your environment workspace path, it basically looks at that location and checks what rasters are stored there. And you can pass different constraints. For example, if you're only interested in listing the rasters that start with the string E, then you can also pass that, and it will give you only the rasters that start with that. Or also you can specify a format, and it would only return the format that you have specified. In this case, I'm listing all the rasters that are stored here. The output is a list. And then simply I can use a for loop that iterates through that list and apply the same clip geoprocessing function to each of those rasters in that list. And that way you can do batch processing. Then with that, I'll pass it back to Norman.
Thank you, Tanya. Thank you, Tanya. Okay, thank you. Okay, so you have already seen the raster object and everything in action. Now we're going to talk about raster analysis using Map Algebra. Okay, so what is Map Algebra? It's a simple and powerful algebra, okay, to execute tools, operator, and function to perform raster analysis, right? It has inputs, operators or functions, and output, okay? Now, the most important thing is the output is on the left-hand side, because if you are familiar with running other GP tool in ArcPy, you'll see the output is on the right-hand side. For raster, for primary raster, the output is in the left-hand side. That's a very important thing to notice, okay? And then the tool and the parameter or optional parameter are on the right-hand side, okay? The strength is in creating the complex expression. We can really create a compact, complex expression, and we'll talk about that a little bit more. And all these tools, operators, and function in Spatial Analyst and Image Analyst module, and you can specify analysis environment using arcpy.env. Environment is important when you are performing analysis, especially raster analysis. Never ignore it, okay? Map Algebra tools and functions. We have all the tools you see in the toolbox, they are all available, okay? There are additional functions also in the module, okay? And Special Analyst image analysis tools and function will require checking out an extension license because it's an extension. Can also use any other geoprocessing tool, okay? Each tool has its unique set of parameters. Some are required, some are optional. You already know about it. And you'll see if you look at the parameters, some of them are number, strings, and other objects, okay? Now, you have to pay a little bit more attention to operators, okay? What are these operators? These are symbols for mathematical operation. Like many operators are available in both modules, almost everything. And you see, in this expression, we're doing in raster 1 plus in raster 2. What actually happening here? You were adding these two raster, right? And that is happening because how we imported the module and we have overloaded it. So if it recognizes that this is a raster, you are now adding two raster instead of adding numbers, okay? You have to actually cast your layer name as a raster object if you want to do this kind of mathematical operation. So be mindful of that, okay? Map Algebra output return the result as a raster object. We discussed that already. It is temporary, and you have to save it by calling save method. Okay, now you can specify the name. If you just specify the name, it's going to your output workspace. If you specify the full path, it's going where it is going. Now be mindful of the format, output format. If you're saving a TIFF, you want to specify .TIFF. If we are saving a CRF, you want to specify .CRF. If you're going to FJDB, you don't need an extension, just things like that. Your extension or the workspace dictate the output raster format, okay? Not all rasters are equal. Different format has different kind of advantage, okay? Complex expression and optimization, okay? This is important because what you can do, you can chain them together and run them in one shot. So if you write a complex expression, it is not doing one thing at a time. It is trying to do everything in one shot. That way it is much faster, okay? Now we mentioned that some of your parameters are classes, and we'll see it in action. And where you can find those classes, where are those things? So if you are familiar with focal stat tool, you will see there is a parameter. It says neighborhood, which has width and height. So those complex parameter, which has some other sub-parameter or other, more than one parameters, those are represented as classes. You can find them and we can use it, okay? And what you can do when you are writing your expression, you can also embed and run a feature tool. We call them feature analysis tool, vector tool, whatever you call it. We have raster tools, we have feature tools, right? So you can write an expression where you have both kind of tools together, okay? With that, I will hand over to Tanya again for a demo.
Okay. Now let's move on with some raster analysis. Now that we have already kind of seen all the raster object basics. In this demo, we will use simple map algebraic expressions. We are going to use functions, complex parameters, and complex expressions, and apply environment settings. And in order to do this, we are going to grab an example from a suitability model. This is specifically looking at the best locations where bobcats can live. And just to give you a super brief overview of what this is about, basically, once you have defined your goal in a suitability model, say looking for the best locations where bobcats can live, now you define some criteria that you will transform so that all of them have a similar range of values, and then you can combine them and get a suitability output map, which tells you what are those best locations. And so in this case, for the bobcat habitat, we're going to be using slope, land use, and distance to streams. These are three criteria that will tell us the best location for bobcats. So let's start by, again, importing our relevant modules and setting our environment workspace. And the first thing that we need to do is create each criteria. The first one is the slope, and we will derive the slope from elevation by applying one of the spatial analyst geoprocessing functions in a simple expression. So here, I'm creating a raster object from my elevation data set that I clipped in my first demo. And I'll give you here one tip. If you are working with a notebook within ArcGIS Pro, if you're doing some exploratory analysis, this environment setting is very useful to set it to false, because this way all the outputs from your exploratory analysis won't be added to the map. So that's why this is here. And now the elevation raster that I was using, it's in feet, but I actually wanted it in meters. So how do I do that? I simply multiply my raster object with the conversion factor. This creates another raster object that I can use as input to the surface parameters function. Note here, surface parameters has many different terrain characteristics that you can derive, and one of them is a slope. That's what I'm specifying here. And for all the other optional parameters, you can pass a blank string to set that option as default. So now I already calculated my slope raster object. But note that you don't have to do this in two different steps. You can chain operations together. In this particular line of code, you'll see that I'm passing to the source parameters function the result of the multiplication, this multiplication operator. And this way, you don't have to create an intermediate output. I don't have to create this elevation_m intermediate raster object. This way, it gets a little faster to calculate a slope. Now, if you recall the workflow, once you have a criteria, you have to transform it. And here's a table to show you how are we going to remap the slope values to a suitability score that reflects the preference of bobcats where they prefer to live. In this case, bobcats prefer to live in very steep areas, so we're going to give a score of 10, and accordingly, we're going to give lower scores to less steep areas. Now, to transform my slope raster, I will use the reclassify function, but reclassify function needs this remap range object, or the output from that, which tells what I'm going to be remapping to, which values to what, right? So in this case, using remap range, you can set, okay, from 0 to 3, I want those values to take a new value of 1. And as I said, this creates another object that you can use as input to the reclassify function. This is where I'm passing it, and it will transform my slope values according to the remap table object that I defined before. Okay, so when we're done with the slope, now we're moving on with the next criteria, which is land use. And land use, typically, it's a raster with different values that represent a class, a land use class, right? Here I have the table, agriculture, type of land use is number 4, etc. But these values obviously don't represent the preference of bobcats. So we're going to be assigning to forest the highest score, which is 10, and to developed areas, the lowest score, which is 1. And the other ones we give values accordingly. In this case, I want to map one value to another, so I'm not using remap range anymore. I'm using remap value. And now this is the complex parameter that needs to be passed here to tell I want to map this value to a new value. So that's what I'm doing here. And this object, again, I'm passing it to the reclassify function to transform my land use. So we're done with the second criterion. And the next criterion is distance to streams. So I have a feature layer of streams that I need to clip to my analysis area. And that's a non-raster function. So you'll note here, I don't have anything on the left side. I have the function, and then I have to specify a path where I'm going to be storing the output. Once this is done, now I can use that as input to my distance accumulation function to calculate the distance to streams. However, you don't have to do this again in 2 different steps. You see how here I have 2 different steps. The way to combine non-raster analysis tool with raster analysis tools in one single expression is by specifying a hashtag on the output path from the feature analysis tool or function. In this way, you are not creating any output, and you are telling ArcPy, I'm creating whatever is the output of this is going to be the input to the distance accumulation function. And that way, you also don't create anything intermediate. So I have now my distance to streams raster, but again, I need to transform it so that the values represent the preference of bobcats. So what I'm going to be using now is the rescale by function not anymore reclassify tool or function. And this function requires you to pass another function to remap the values, right? And in this case, I use this function because it rescales the input data by assigning a higher preference to smaller values. That's exactly what we want, right? Bobcats want to be closer to streams. So rescale by function gives us the distance to streams transformed. Now, lastly, combining all our criteria, all the criteria that we calculated. And it's as simple as just specifying a weight and summing them together. Since all these are raster objects that are the output from the different functions that I run, this output is again another raster object. And you can you can use the render function to have a better visualization in your notebook. And here's the output. Greener areas is where bobcats prefer to live. Now, all this analysis was a little bit of exploratory analysis. Maybe I want to use different remap tables or different functions. So once you're already settled with the type of analysis you want to do, you can combine everything in a single complex expression. So that's what I have right here. For example, for a slope transformed, once I'm already happy with surface parameters selection and the remap range table that I want to use to the reclassify function, then I can nest everything in a single expression and run it. That way it's optimized and returns the output of interest. Note that I defined some output environment settings right before this operation happened. That way, the output of this operation it's in the settings that I set, right? So cell size 100, different output coordinate system. Here, the input cell size was 30. My output cell size is 100 from this slope transform operation. as well, that's the same thing with the coordinate system. So if you want to have an output in different cell size or coordinate system or other environment setting, you just need to specify right before running such a statement. And I think with that, this is the end of demo 2. I'll pass it back to Norman.
Thank you, Tanya. So Tanya actually went through a relatively complex analysis, where you can actually use ArcPy very efficiently. But this kind of analysis, if you want to do interactive way, we also have suitability modeler as the UI part of it, Okay. Most of you are probably familiar with NumPy, but why are we talking about NumPy where we have all the other things to talk about? Well, the reason is very simple. If you think about raster, and if you take away all the color, what you have in each cell is value, which is very similar to an array, okay? So a raster is nothing but an array. That's why NumPy array is very useful when we're talking about raster, okay? It can be used to extend our existing capability to do custom analysis, okay? It's an extension package to Python, you know about it, and all the exciting thing that it can offer, okay? How you can get a NumPy array from raster? That part is very simple, okay? Now, earlier we have one way to do it, which is raster to NumPy array function. It's very obvious. Another one is NumPy array to raster, okay? You cannot miss it. However, to make your life even much more easier, what we have done, we have added read and write function in Raster Object. So the moment you say read, what you are getting back is actually a NumPy array. And then you can also write a NumPy array to a raster, okay? While you are actually working with all these things, one thing becomes really handy is PixelBlock. Because if you are working with a large raster, you don't want to read everything, you might actually read block by block. Okay, so you used to have ArcObject method for PixelBlock, but now we have Python. In ArcPy, you can get PixelBlock, and you can get a PixelBlockCollection. Then from that, you can get PixelBlock, and you can actually loop through it, and you can work with it. But when you get down to work, you really need to work on a cell level. So how do you get to a cell level? So we have created what is called raster cell iterator, which lets you loop through individual cell in a raster, okay? And then once you go through it, you can also look up, down, left, right, surrounding, because we have this relative notation going on here. We have several blogs you can look at. The important thing is raster cell iterator give you pretty much direct access to your cell and your neighboring cell, and you can perform a lot of custom application or analysis using that, okay? With that, I'm gonna hand over again to Tanya to show you a demo.
This is the last demo. And in this one, we're going to be looking at creating custom models and analysis using that raster cell iterator. The learning objectives, as I listed here, are the basics of raster cell iterator, also what kind of custom analysis you can do with RCI or raster cell iterator and NumPy, and how do you share that custom analysis. The very first thing I want to show you is that once you have already defined a raster object, you can access the value of any given cell by specifying the indices, row and column of that cell that you're interested in. So in this case, for example, I have my DM raster object. I want to look at the value of the first row and the second column. What I need to do is just index on that. and that this is what it returns. It returns the value at that cell. So that's basically what the raster cell iterator is doing, iterating through each cell and looking at the values of that cell. Here is a very basic kind of piece of code, a snippet, with a raster cell iterator. So you have raster cell iterator, and you pass here the rasters that you want to iterate through. One raster that has information and another raster where you want to store the values of the new analysis that you do with this input raster. So what it's doing is, okay, for each index in these rasters, apply something, do something. This is the algorithm that this is where the algorithm that you want to do goes, right? So in this case, very simple. Okay, in my new raster, at that specific cell that you're looking at, I want to store the value of my raster plus 10. Very simple, right? You can do much more complex things than that. Let's take a look at one example problem. For example, in this case, calculating the steepest downhill neighbor slope. This is an algorithm that we don't have a tool for in ArcGIS Pro, so I need to do it by myself. Let's see what this algorithm is about. It basically picks the steepest of the 8 adjacent neighbors, the slope value. So if I'm looking at a center cell, so this 8, I calculate the slope in each of the 8 directions, and then I select the one that is the steepest. So in this case, the one going south is the steepest slope, and on my new raster, I want to assign that cell that I was analyzing that specific steepest slope value. So you can use raster cell iterator to code this algorithm. Let's see how that would look like. So the very first thing is to define our raster object, just as we have been doing before. And we need some of the elevation raster properties for the calculations. So that's what I'm defining here, the width and the height that's used for slope calculation. And then I'm going to create a new raster that is going to contain the values of the calculated slope. I want it to have similar properties as my input raster, so this DEM. So I get all that information from my input raster. However, note here that this DEM pixel type is an integer, and slope calculation is likely to be a floating point, right? So if I don't change that, at the time that I want to store those floating point values, is going to throw me an error. So I need to set that new empty raster pixel type property. I need to set it to floating point, and that's what I'm doing in this piece. Now that I have changed that property, I can pass this raster info object to raster again to create that empty raster with those properties. And now, moving on with the raster cell iterator part. I'm passing my elevation raster object and the one that I created where all the values are going to be stored. And I'm iterating through each of the cells. And as I mentioned before, you need to calculate the slope for the 8 directions, right? So we're going to be iterating through each of those 8 neighbors. And we use a relative notation to where I'm already looking at. So if I'm at RC indexed cell, then I just need to specify, one row before me, one column before me, to look at the surrounding, right? And once I'm looking at each of those neighbors, then I can calculate the slope, store that in a list, and then just get the maximum, which is going to be the steepest, right? Once I have that, I assign that that steepest slope value to my empty raster. And that's completed. The algorithm is implemented. Now, again, that it's a temporary raster. You have to persist it. If you want to save it, if you want to make it persistent, you need to save it. So that we save it in here, and we have calculated our new slope with the steepest slope value. So you can see Raster's Iterator is very useful for doing any type of custom analysis that we don't have currently as a form of a tool. And you can share this by creating a script tool, let's see, where you can just embed all the piece of code that I was showing you. You can just embed it in here and simply create your own tool, which is very simple to share with your colleagues or with anybody else who wants to also run this kind of analysis. And I think with that, this is the end of the demo. I'm passing it to Norman again.
Thank you. Thank you, Tanya. So what is the moral of the demo? If you don't find a tool, just create one, okay? Don't complain, okay? I'm just kidding. No, it's really powerful. It's really powerful if you want to create a custom analysis using all the, from raster cell iterator, PixelBlock, RasterCollection. If you look at it, we have actually over time provided a lot of functionality to make your life really easy. And creating custom tool, script tool, is not that hard either. Many of you have done it already. If you write a code, stick it there, and you just have the UI and everything, just, framework take care of that. So, if you want to solve a problem, and for some reason you think that, putting together a bunch of tools is not really working, then as a last resort, you can actually look at this kind of option and really quickly put together your analysis solution, okay? Okay, let's see, what is the next thing? Raster analysis and multiprocessing. Now, given the size of the raster we have to deal with, and given the fact that we now have faster computer, better with multiple processor, there is no reason to take advantage of multiple processor to do multiprocessing, okay? Now, the good part is you do not have to do it yourself. In most of the cases where it is advantageous, we have done it. The reason I'm talking about it where we have not done it, if you need to do, you can do it, okay? Now, when you do it, you have to think about the type of function that you are running. If it is a local function, that means you are actually working on a one cell at a time. What is the example of that would be? Adding two raster, right? You just need to look at one cell here, one cell there, you add them together. That's the definition of local function. Focal function, where you have to look at the surrounding. The example that Tanya showed, you have to look at the 8 neighbors. That's a focal function. Zonal function, you have to look at all the cells under a zone, different regions. That's a zonal function. And then global, you have to look at everything. Now, as you go down this list, parallelization becomes harder and harder, okay? So the local function and focal functions are pretty easy to do. Going to zonal and global are very hard to do. We have cracked that nut, we have done it. Most of our distance tool, hydrology tool, all those focal functions, zonal tool, we actually do parallel computation and distributed computation. So don't spend your time doing that because it's already done. Okay, you just run it, it happens. Okay, but if you look at it and say, because one thing that you can control is the parallel processing factor environment. So before you think that you can just use all as a processor and you will get a faster result, that may or may not be true depending on the type of the operation. And don't forget about the I/O speed. Anyway, as you can see that as the number of processor increases, we get it becomes efficient. It can get it faster, but not, this trend does not continue. At one point it flattens out, so you don't have any benefit, okay? Here is a simple example how you can actually do it. Some of you have done it in Python. I'm not gonna spend too much time about it, talking about it. It was much more relevant earlier. Nowadays, it's becoming less and less relevant for the operation that you do in our ArcGIS, okay? Because we take care of it. Where we don't take care of it is either really not beneficial because computation time is not much, it's the I/O, that's the bottleneck, or it is really difficult, the overhead is too much, and you don't get much benefit. So we are continuously assessing the situation, rewriting the algorithm. Sometimes we are going after parallel processing, sometimes we are going after GPU processing, so depending on what works for us, okay? And what will give you the better performance, okay? But there are some blogs that you can look at, something to talk about vector processing, something to talk about raster, something talks about raster processing, so you can take a look at it and get an idea of what's going on, okay? Now, in summary, what we have done today, okay? Using ArcPy, you can visualize, explore, manage, analyze, share raster data, okay? You can do everything. So I'm a raster guy. It is very important for me to talk about raster because you cannot pretty much do any analysis, any complex analysis without having one or more raster data, probably, right? That's how things are happening these days, okay? Use ArcPy, IA, and SA module to primarily work with raster, okay? Raster object is your friend. It represents a raster. You can work through that, and you can have properties, methods, and everything. Map Algebra is your raster analysis friend, because if you can write a nice expression, you can solve a lot of problems, okay? But as I said, to perform any analysis, you need raster, you also need vector, and often you have to combine these two together to perform analysis. So ArcPy gives you that flexibility. You can combine them together, okay? If you forget the output from a raster expression is temporary, don't blame me, don't call me, it will disappear. It's your responsibility to save it. Keep saying it again and again, year after year, still people lose their data and they'll say, what happened, right? We took care of it, right? We deleted for you, okay? The raster object is temporary by default, okay? And then again, if you don't have any analysis function, don't call us. No, that's a joke. Call us. Let us know that you need a new functionality, but don't let that stop your work. Just look around, see what other functionality are available. In Python, you have a lot of good functionality available these days. If you can create a NumPy array, you can probably send it to another function, get your result back, put it back as a raster, life is good, okay? So you can extend your analytical capability by doing it. That's all I have, and don't forget to send your feedback so that we can improve the demo, our slide, or the session, if we can include other subject matter, so that would be really beneficial. Thank you. Any question? Yes, sir.
Yeah. No, please. Second person. Yes, there is a repository, GitHub repository that will be shared with everybody. All the sessions that have demos with code snippets and everything will be stored there, and those will be there too.
Just in case, you can get his card, her card, and then we can email.
Sure, yes, of course, that also.
That was your question. Okay, yeah. Sure.
Can you speak to data sets you're working with grow very large, with like the Map Algebra or the other spatial analysis tools, do these tools work all in memory, or will you run out of memory, or will they kind of swap basically?
Well, that's a really good question. The question is, I'm paraphrasing, right? Is there any limitation? Are you going to run out of memory and whatnot? We try our best to write algorithms so that it scales, right? You saw in the plenary, trillion, billion cells, you know. Now, is it possible that there are some operation that we are relying on memory and you may run out of memory because your computer doesn't have enough memory? Possible, right? Because at that point, writing the algorithm to page it and do it has become expensive. Memory is getting cheaper and cheaper these days. So it is possible, but that is becoming less and less concern these days. The way we write program needs to scale and perform, okay? Anything else? Yes, sir.
With the Map Algebra, I would assume those rasters are all sort of row, column, cell, and line. Is that correct? They have to be, if you want to add one raster to another, you have to have the same number of rows and columns, same CRS, aligned perfectly. Is that correct, or is there flexibility?
For what? For any kind of operation?
Well, let's say you had a 30-meter elevation surface, and you had a 10-meter land cover surface, and you wanted to do that bobcat exercise.
Yeah.
Even if they're in the same CRS, there are different cell size. How does the Map Algebra deal with that?
Very good question. So again, I'm going to paraphrase. Can you mix different cell size, extent, special reference? Sure you can, okay? Of course, we will find a way to do it. What we're going to do, depending on the analysis cell size, so by default, if you use a 50 meter with 30 meter, we know that if we change 50 meter to 30 meter, we're going to give you a false impression of accuracy. So we're going to fall back to 50 by default, and we're going to start resampling, and internally, unless it is a surface operation, we're going to use nearest neighbor, and based on that, we will create an output at 50 meter cell size. If you specify 30, then we will resample the 50 to 30 and do it. You can also specify 10, we will resample. We will keep adjusting it. But think about it. It will work, but is that what you want? What happened to your analysis when we are continuously doing resampling and neighborhood, right? Using neighborhood method. So my suggestion, pay attention to special reference, cell size, extent, snap raster, cell alignment. If you need to mix and match, be my guest, do it, we will produce output. But then complain why output look like that, because if you have a large cell, one value, very varied cell with another one, and then you suddenly expect a very detailed result, that's not going to happen, okay? So computer will work, but remember, garbage in, garbage out, right? So you have to pay attention. And with raster, I cannot emphasize enough to pay attention to your special reference you're using, cell size you're using, cell alignment, which control through snap raster, all those kind of things. Okay?
So
yes?
you're basically taking a series of hierarchical assumptions to make it work.
Yes, yes. Say it again?
It's documented everywhere.
Yeah. So there is actually a very nice high-level document about how we do analysis environment, what happened with that, right? How we go through and systematically keep adjusting things and come up with a default or adjust everything. We keep writing about this thing, we keep talking about this thing because this is a common thing that people kind of overlook, right? And especially coming from vector world, right? But with raster, you have to be a little bit careful about it, right? And especially when you are doing conversion and you don't pay attention to the cell size, a lot of things could go wrong, right? Yeah.
Raster, but I don't know if I saw like the snap raster or the resolution defined.
That's why it's called demo. Yes. Yes. So she mentioned something about environment, right? And when we control a lot of things in the environment and we run operation, it starts to adjust itself, right? It uses the right cell size, it uses the right snap raster alignment. So anything that's getting produced in every step actually consistent. So when you combine them at the end, they are all consistent. Okay? Yeah, this is a good question though. Yes, sir.
Again, just a little further to that, so the CRS is the same, and even the resolution is the same, but they geospatially are aligned. Then you would use like no data value, or like
Snap raster.
you're summing two grids, and then you have there's no cell value in the other grid. It'll just keep the same.
That's another interesting point. Who knew adding to raster would be so difficult, right? I'm actually asking one of my team members to write a blog about it because so many people get tripped off by that. So think about it. If you have a raster here and a raster here, and you're trying to add them together, what do you expect? This value, this value? Well, I'm not going to give you any value. This is why. Because when you add a value with a no data, which means it's an unknown with a value, you get unknown. Because if I give you a value, you may think that it did the right work. So anytime you are combining anything with no data, you're going to get no data. Only few tools give you option to ignore no data. Only few tools. In general, be aware of no data. So, and then also extent. What is the cell size, default cell size, I say, when you mix them, the larger one. When you don't control extent, what is the default extent you get when your extents are not fully overlapped? You get minimum of. So we're going to work with the area where both are overlapped. Okay? So we kind of instill some of this safety net, but we cannot make it bulletproof. Okay?
But you have a document. What's it called? Is it just like Map Algebra background?
Yes, there are many concept docs. So what I suggest you guys to do is when you look at the toolbox and tool references, in every section there is a concept section. And in concept section, we explain all of this thing in detail. Okay.
I just had a quick comment about scaling. Would it scale better if you do not convert formats? For example, if you're reading from tip to tip, it should scale better because the underlying code is like ESQ, or like in terms of how it's reading, it should, in theory, scale better.
No, it will work. Don't worry about it. We take care of it. Okay, if you have more questions, please come to the showcase. I'll be there, okay? Thank you again. Thank you for your time.
Thank you so
Okay.
much.